Hello everybody, welcome to this session webinar. We are going to start our seminar, and the one who is speaking right now is the speaker, and my name is Kabuyaya Kigutadan. I'm really happy that you are joining us in this webinar. First of all, I have to share with you my contact. As you can see on the screen, my WhatsApp number and my email. So whenever you have any question to ask, or if you want any customized session, you can email me or phone me on using this number. Today's subject is about seismic design of reinforced concrete building using Midas Gen. I hope that you are familiar with this material, reinforced concrete, because it's the material that is used all over the world in the construction companies. So today we are going to focus on the seismic design of reinforced concrete building using the software called Midas Gen. So before we start, I'm going to introduce you the content of our webinar, and the first point is about the introduction. So I'm going to introduce a little bit our company and our different product that we have, the product that brings solution to the engineers all over the world. So the second point will be about the seismic design procedure. So in this point, we're going to learn the procedure, the steps we use to make the seismic design for reinforced concrete building. The third point will be on the reinforced concrete building modeling, and then we are going to demonstrate using Midas Gen. Lastly, we are going to check the result and report detail generation. I'm going to share with you again the secret, the top secret for you to master the software that we are using in our company, Midas IT. So the secret is that a lot of people, they want to know about our product, but they don't really ask questions about training. The training in our company is free. So when you want to learn about our product, feel free to send me an email, or you can text me on WhatsApp, so we can customize some section, and then we can make a schedule. You can learn easily our product, and you can apply directly the product in the project you are running in the company. So usually we perform online training depending on the demand of the company, and sometimes we can do hands-on training in different places. As you can see on this picture, in our company we can do also hands-on training with our clients. So I have another good news for you, and all those who has attended this webinar will have a discount of 30% of the product Midas Gen and other products we are selling in our company, like Midas Civil and other products. So make sure that you attend from the beginning till the end of this webinar, and then you are going to have a special offer of the product we are going to introduce you today. I hope that after this webinar, you are going to send me emails and ask for the training, and you can ask even for the PO or quotation if you want to learn more about our product. And the other point is that if you don't have the software, you can first download the free trial on our website, and then you can check, you can evaluate it. But in order to know it very well, you need to customize some session with our technical team, and then we are going to help you to understand better the function and the capacity of our software. So in the introduction part, we are going to make a brief description of our project. The project we are going to working on is it's a building, RC building. As you can see in this picture, we have the front view of the building, and we have also the top view of the floor, and you can see that our building is irregular in elevation, and we are going to use dual structural system in our modeling, the shear wall and with special moment frame. So special moment frame are really good in designing reinforced concrete members, because it's really economical when you use this type of system in your design. So the seismic zone, we are going to use a high seismic zone when we are going to analyze. The methodology we are going to do in the design, we are going to use the response spectrum analysis and P delta analysis. So I know that a lot of people there, they do know about this, but sometimes they can misuse this concept. So today I'm going to make some clarification of this method using our product Midas Gen. And when you have question, please, you can write your question down in the question field. Even if you can send me an email, so after the webinar, I will try to read the email and answer to different questions you are going to ask. So this is the model we have. Before we start, I'm going to explain some theoretical background about the response spectrum analysis. So these are the steps we have to follow when we are doing the seismic design. So first of all, we have to do the performance requirement, and we need to analyze the soil, the ground we are going to place our structure, and then we are going to check the seismic action, and then the combination of seismic action. The next point is criteria for structural regularity, and then we're going to make the analysis. Then we can verify. We can use even the capacity design and detailing using our software Midas Gen. So the different method we have to analyze for the seismic design, we have the lateral force method of analysis, and then the model response spectrum analysis and pushover analysis. And lastly, we have the inelastic time history analysis. So to cover this topic in 1 hour, it's not easy, so we are going to focus on the model response spectrum analysis in detail using Midas Gen. But even if you have questions about other analysis type, you can ask, so I can give you the answer. So for the pushover and inelastic time history analysis, because they are non-linear, we are going to focus on the elastic system using these two methods, lateral force method of analysis, and we are going to compare the two methods, and you are going to realize that the response spectrum analysis is the best compared to lateral force method analysis. For the performance requirement, as you can see that when we are doing the seismic design, we need to check the overturning of the structure, sliding, plastic rotation, and we have the structure have to have higher resistance. So this one, you can see this, the return period, the reference return period we usually use in the building code when we are doing the seismic design. This is the formulation of the return period. By definition of this return period, it's 10% of the exceedance of probability in 50 years. So it's a probability that help us to assess the seismic event. You can see that it's written we have to focus on no collapse of the building. It sounds crazy because when the earthquake occurs, the building has some damage and it can collapse sometimes. But as we are engineers, we need to figure out the technique to do in order to protect lives, people who are living in the building, the equipment in the building, and other expensive equipment that we can find in the building. So the first thing to think about is about saving lives in the building. The other point to check is we have to make the limitation of damage when we are doing seismic analysis. To do that, we need to check the interstory drift and the resistance of the structure using the ultimate limit state parameter. We need to figure out the ground type. So whenever we do any construction, we have to analyze the ground. So even if in seismic design also, we need to check different parameters for the ground, if it's rock or stiff soil or flexible soil, and different period according to the soil class that we are going to see here. We have different class of soil, as per Eurocode 8. So we have different class A, B, C, D, E, S1 and S2, and these are the speed of the wave of the seismic force, and this is the geological amplification coefficient that is represented here in this column. So after you select the soil, you need also to define this period of the response spectrum. As you can see here, there are 4 points. At these points, we can find them when we have the data for the earthquake. After getting the data of the earthquake, we can identify this point as B, C, and D. B in this their period in seconds. So when you have the data for a spectrum, depending on the soil type, they are defined in this table, and they are given in the code Eurocode 8. So I tried to prepare this table for you to check the value of this period based on the class of soil. And this one is just the horizontal spectrum response. So the other important factor to know about is the importance factor, and this factor helps us to assess the protection level of the building against the seismic action. Some building, when we are erecting them, we can assume that they are very important depending on the number of people that are going to use the building, and depending on the material, the equipment that we are going to put in the building. So based on those factor, and the most important factor here is to save life in the building. So for the building which doesn't have many people inside, we just give the important factor of 0.8, and the second class for the building is just 1. So the third class and the fourth class category, the seismic design is required. From class number 2 to 4, seismic design is required. But someone also who want to build his house according to seismic design, it depends on the contractor. So if you want to the single house, if you want to make it earthquake resisting, then you can do that. It's not a must that someone can perform seismic design of his house, his own house. But for most of the case, we think about important building in the society, like hospital, fire station, power plant, and etc. So for those kind of building, we must perform the seismic design. And the important factor for those important building, it's 1.4. So for the analysis method, we have different method to use when we analyze the structure and the seismic action. We have the first one is lateral force, and the second one is response spectrum analysis, and the other one is pushover analysis. And the fourth is a time history analysis. We can do that also to do the analysis, but we are going to compare this first analysis, lateral force, and response spectrum analysis. And then after, we are going to make some demonstration using the software. So we are going to make any difference between these two analyses. So for the lateral force analysis method, it's a static method, and we calculate the seismic load using the base shear. But for the response spectrum analysis method, we use model response to calculate the seismic force, the seismic load. So that's the only difference between these two methods. And this one is dynamic, this one is static. The method we usually use is this one, and we are going to learn the advantage of this dynamic response spectrum analysis. So the next slide, it's about the difference between the two analyses, when we can use them. So when you have a building, there are some regularity that are required in the Eurocode 8. And those regularity should be in plane or elevation. When you have the plane regularity, when the building satisfies plane and elevation regularity, you can use both methods without any problem. And both of them, they are linear elastic method. When a building satisfies the regularity in plane and elevation, you can use the lateral force method and the model response method for response spectrum analysis. But when the regularity in plane is satisfied, but the elevation regularity is not satisfied, you can use only model response for the analysis. And when you have when the plane regularity is not satisfied and then elevation is satisfied, you can use both method. But when the plane and elevation regularity are not satisfied, you can use only the model response. So that's why in your design you should use the response spectrum analysis when you are doing the seismic design analysis. So you can check this building here and you can see that this building here is irregular in plane and in elevation. So this kind of building, to make the seismic design of this kind of building, you need this response spectrum analysis. So because the lateral force method is really limited, so you can choose the response spectrum analysis. So these are the picture that shows how we calculate the shear, the base shear according to each mode here of the figure. When we have the mode 1, then the software will calculate the base shear accordingly. And when you choose even 10 mode or 10 frequency of the shape, the mode, then you can perform those analysis using eigenvalue analysis. Then you can have the seismic force that you are looking for. The other point is about, this is how we can define the number of frequency. Number of frequency correspond to the mode. So the number you are going to specify here is the number of the mode you are going to have. The deformation of each mode it depends with the number of frequency of the structure. And in Midas Gen, we have that option, and this is the dialog box for that input. So the other most important thing here, when we are performing the response spectrum analysis, we need to check the model participation of the mass. Based on the design, it said that the mass participation percent have to be over than 90%. So before you do the response spectrum analysis, you need to check this condition if it is satisfied, because the mass participation have to be more than 90%. I will explain that when we are going to perform the demonstration, because right now maybe you will not understand very well, but when we are going to go to the demonstration, you will understand very well. This one we have to check, and that's what I was explaining. According to the code, the mass participation of the structure must be more than 90%. So the response spectrum analysis in Gen, when we are using it, you can define the response spectrum function you are going to use for your design. And we have design spectrum here based on different code in Midas Gen. You can choose the one you want, or if you have the data, you can input them here. You can copy from Excel and paste them here, the period and the spectral data for the acceleration, the ground acceleration. Then you paste them here, and then the software will draw the graph here. So after drawing this graph here, you can realize that the software is able to specify the different points, the different period that I told you. The point we have here S, and then here we have B, C. I don't know if you remember very well. So those different points, they are automatically given by the software when you give the data for the design spectrum. And after clicking here, you can select. You can see this one is an example for Eurocode 2004 for the horizontal design. We are going to use also this spectrum data in our example. The ground of the other spectrum parameter we have to check it's the ground type, the seismic zone, and then importance class. I explained this before, so we can jump this one. And then for when you have the spectrum data, you can have directly the data, the curve of your data directly using the software. So using the acceleration period spectrum graph, you can have those periods that are previously explained, those period TB, TC, TD, and S. So this is the dialog box we use in Midas Gen when you are inputting the response spectrum load case. You need to define the direction of the seismic force. In this case, we just define in X, and then you need to specify the direction of the seismic force. If it's going to be in X, Y, or in Z direction, you need to specify that using this box. And for the excitation angle also, you can choose any angle you want, or if you don't know the angle, the software can give you automatically the angle you are looking for the type of building you want to design. And the other point to check is about the model combination control. So when we are going to make the demonstration, I'm going to explain this part in detail. So now, because I didn't open the software yet, so to understand those functions is not easy, but when we are going to practice it using the software, then you will understand very well. We can continue. And so this is how the base shear is calculated using the response spectrum analysis. So for those mode number 1, number 2, and until the number of frequency you specified in the software will calculate the base shear, and then it's going to sum them up using the combination method to calculate the base shear force. The famous method here is the square root of sum of the square, but this day we usually use the complete quadratic combination to calculate the base shear force. So in our example today, we are going to use the complete quadratic method. All of those combination methods, they are in the software, so don't worry about that. We'll explain it when we are doing the demonstration. So sometimes people they can make some confusion between the damping ratio and the damper. So we need to understand also those differences. So for concrete, we usually use the damping ratio for 0.05, and for steel structure, we usually use 2%. For pre-stressed concrete, we usually use also 2% of damping ratio. And for the composite material, you can define separately the damping ratio in the software, and the software will analyze the damping of the composite material you are going to use. If you are using the steel concrete composite, so you can specify their damping ratio, and then the software will calculate the damping of those both material using the energy method that we are going to see in the software very soon. So what I was explaining, that for the damping ratio, for the concrete, if you have the mixed material in your structure, you need to specify the material and you input the damping ratio of that material based on the code. So the software will analyze. You can, after inputting the damping ratio of one material, then you are going to hit on add, then you put another damping ratio and then you click on add. Then after adding those material, then the software will calculate the damping of that group of material easily using the energy method. So this is the first step. I'm going to explain the modeling in Midas Gen. The first step to do when we are doing the project, we need to select the material we are going to use, and then we specify the section and their size. And after that, we can also specify the thickness of the wall, because in our structure we have the shear wall. So we are going to have the concrete is the main material we are going to deal with, and we are going to define 3 sections for the edge column and the interior column, and then the beam in the structure. The third property, we have the wall, the shear wall, and its thickness. So these are the dialog box we use for property, for material property and section properties. And this is the second floor for our building we are going to demonstrate very soon. And this is the render view in Midas Gen. This is also the load cases we are going to use in our model. We are going to use the dead load, live load, wind load on the structure, and then the earthquake. But you realize that this one is static load cases. So before we perform the real dynamic analysis using the response spectrum analysis, we need this analysis. We need this static load case that we are going to use in eigenvalue analysis to check the mass participation in the structure and their distribution in a different direction. So after checking that, then the response spectrum analysis can be done without any problem. Yeah, I hope that you will understand when we are going to do the demonstration using the software. So this is how we apply the flow load in Midas Gen. It's really quick, and compared to other software, the application of flow load is really quick and accurate here in this software. And this is how to define the wind load. You just need to input different parameters required by the code, and the software will generate the overall load, the wind load on the structure. So in this case, you have to select the category of the ground, the terrain category, and then the friction coefficient of the wind, and then you need to put also the basic wind velocity in the area you are going to build your building, and then directional factors, seasonal factors, these kind of factors. You need to put their value depending on the area you are going to construct your building. So the building height also is required in order to calculate the wind load. And then the windward and windward and leeward coefficient, you need to put them. But if you want to define them by yourself, then you can choose user defined, then you can put the value for what you have according to the area. And the other factor that is very important is structural factor, called also cast factor coefficient. So this one also is calculated automatically in the software. I will show you how it is calculated automatically here. So everything in Midas Gen is really automatic. You will love this software where you are going to use it, I promise you. So if you want to apply additional wind load also, there is the the function that you can use also to add additional wind on different floor. So if you want to add additional wind force on the building, you can select the floor and apply on the specific floor. That's what we call additional wind load. So if you hit here on add, then the software will bring you the dialog box when you can select the floor where you are going to apply the wind. Similarly, for the this is one is for X direction, the wind in X direction, and then you need also to specify the wind in Y direction. So that's the direction we need to check for the wind, two direction X and Y. So the next point is about the seismic load. So I used for wind load and for seismic load, I use Eurocode. So I use also the Eurocode, the horizontal design spectrum, to define the seismic load, the static seismic load. So we have also to define the direction of the load. If it's in X or Y direction, then we have to put also the angle, the excitation angle, the scale factor, the period modification factor, and we need also to check about the model combination control. This one is important. And then you have to select the function you are going to use, this function that you select in the response spectrum function. So this function have to be linked to the load, because this is the load that we are going to apply on the structure. Then you should also specify the interpolation of the spectral data, but in our example we choose linear. And also we need to check about the accidental eccentricity. So after specifying this parameter, these few parameters, then the seismic load, the static seismic load, will be generated automatically, and it will be applied on the center mass of the structure. So now I'm going to open Midas Gen, and then we are going to check if we understand. But for the theoretical part, I didn't want to bother you with the theory, so we can go right in the practice. So about the theory, you can check the code very well, and the coefficient we need to calculate and input in the software. Those coefficients are really important to know, so you can make a good design. So this is the window of Midas Gen. This software is one of the powerful software that can design and analyze any type of building structure. So I'm going to start the model. Before starting, you need to specify the unit you're going to use. You can change the units you have anytime you want. I'm going to use pound and feet. So here, a lot of people there in Africa, we don't usually use this unit, but I'm going to change later in meter or millimeter. So that's not a big problem, because in this software you can change the unit whenever you want. So after choosing the unit, then you can hit on OK. And the first thing to do is to specify the grid line, because the grid line are going to help us to make the model quickly. So in structure, you can specify the type of structure you are going to use. Is 3D structure, and then you're going to hit on OK. The first point to do is just to define the material, and the material can be defined in the property menu. Click on material, and then you click on this tab, material, and then you click on add. Then you can select the material you're going to use. Let's put concrete, and then you can select the code you are going to use for for the concrete, I can choose a BS and select the concrete width 30 megapascal. So I can hit on OK. So this is how we can define the concrete material, and we can define section. As I told you before, we have 3 sections we are going to use. The first section we can, before inputting the section, the data I have there in inch, so I can change the units in inch. So for feet to inch, then I can input the data for the section. So the section, we are going to use a solid rectangle, and the first section, let me call it beam, and I'm going to use the user define. The beam has 24 inch times 20. Then I'm going to hit on apply. The second section is the H column. H column, it's 24 times 24, and then the interior column are 30 over 30 inch. So these are the section we have. So we can define also the thickness of the wall. The wall thickness we are going to consider in plane and out of plane, and then I'm going to hit on apply. I didn't put the thickness. This is wall, and then I put here the thickness, and then I hit on OK. So that's the thickness of our model. I'm going to go a little bit faster because the time is running. So if you want to define the time dependent material of the concrete, you can hit on creep. So I can enter the name of its creep and shrinkage. So you can select the code you want here. There are a lot of code, so I chose this one from Europe. And for the characteristic compressive strength, I put 28. For the national size, I put 100, the type of cement, and then the beginning of shrinkage. The age is 3 days, and then the type of aggregate, I select that's the default value. And then you can see the result you have for the creep, and then we can close this one. So okay, we can save first our project. We can call it webinar RC. So we can close this one and hit on apply. The name is creep. So the creep function here is defined, and then okay, the other time dependent material is the compressive strength. So here also I can put the name comp as compressive. I chose European code, and then here I can put the value I want, cement, and then the aggregates, and then I select. You can check the value, the graph of the compressive strength, and then you hit OK. Then you close. So to link the concrete we define, you need to click on material link to link the creep behavior and the compressive time dependent. You have to select the material, and then you hit on add, and then you have defined the time dependent material for concrete. So to make the model, we have to go to node element and create element. This is how you are going to create the model. But first of all, we need to define the grid. So we are going to use XX plane, and because I know the structure, how is it, I'm going to start for the second floor. But here we need to be careful about the unit we have. So I'm going to put here foot because the data I have there in feet. So I'm going to start the model from the second floor, and then I click OK. So I have to define the grid line here. That is going to help me to descend to make the model really quickly. So the name is user define. So this grid line, we have to define them. The grid line we have, it's 26 feet, and then OK. For this one, for Y direction, we have 3. distance of 22 feet, and then we can click on add on OK, then we click OK. So to check our grid line, we can change the position of the view. This is how the grids are created. So using this grid, we can design very quickly the model of our building. So we can go to node elements and create element, and we'll have this dialog box here. So first we are going to model the beam of the second floor. So I can check this intersect node element, node connectivity, and then I will start here for the beam. So you can change also the color of this, because a lot of people, they don't like this kind of color when they are doing their model. We are going to change it, don't worry. So this space is for the wall, so I left it like that. So if we want to change the color of the section we are making, we can go here in display property and can choose any random color. Now we can use that color. That one is better. So this is the first, the second floor. So we can change the view of this floor. We can generate the column. For the column, we have to extrude the node to the line element. So we have to select first all the structure. We need to select all the structure we made here, and then we click on extrude. We are going to extrude node to line elements. We have to reverse this I to G, the end of the element, but we are going to use the section H column, or we can use even interior. There is no problem. We are going to put the distance of minus 16, and then we hit on apply. So you can see that the software can even give you the color directly. It's really beautiful. The top view of this one is so I'm going to model the wall in this space here. So I have to select this thing, this 3 beam, and then I return to, I can activate only this part, the selected parts like that. I change this the view, so I will define here the wall. So to define the wall, I need to go to create element, and then I select the wall element here. The material is concrete and the thickness is given there. So I need to go to node connectivity and click on this node here to make the model of the wall. That's how we can create the wall. So I told you that we have 2 walls here. So using the translation feature here, we can translate this wall and all its property. So we can input here just the distance. It's 130 in X direction. It's not Z direction, but X direction. So we need first to select the wall, and then we have to put here the number of increment of the ID, and then the wall is going to be created there. So we can activate all the structure like that. So we have all the wall. So after having this, we can generate the building. Okay, before generating the building, we can assign the property to the interior. Okay, after selecting the interior column here, we need to assign the value of the edge. So we can activate all the column like this. So because these are the interior column section, because we have two sections, so we need to identify the interior column from the edge column. I'm sorry for the time. We are going to assign the property of the edge column on the structure. So we can go on the top view and select only the edge. You can select only the edge column here. And then we can assign edge column like this by drop and drag here. Then the column has been, we have two sections for the column, the interior column and the interior, the edge column and interior column. So we can activate all the structure, and then we can go to define to generate the building. So for generating the building, we go in structure and then building, generation of the building. So the copy of the building is 11, and the distance is going to be 12 in Z direction. And then I can click add, and then I need to select all the structure I have here and to check on copy attributes and then apply. So this is how we can generate all the building, the boundary condition. So we are going to use the simple one. We go to boundary condition and then define support. I'm going to define fixed boundary condition for the column. So I will select the boundary condition like this and then click apply. So the other point to do is to generate the story data. In structure building, the story data here, we need to click on auto generate and then click on OK. So the software will generate the story data, and the more important one is about the flow diaphragm. So the software is able to specify to consider the diaphragm on each flow. So but if you want to change to do not consider, then we can select do not consider, but automatically the base of the building is, we don't consider the flow diaphragm on this floor. So that's how we can generate them, because the diaphragm, it's the most important element we have in the design, the dynamic design of the structure. So the other point is we can define the load, the application of the load. So we can go to load. We can define first the different case we are going to use to apply the load. So we have the dead load. We have to select the type and then click on add. We have the live load and then we select live load and then add. We have the wind load in X direction. We select wind on structure and add, and we have also the wind in Y direction. We click and have add. We have the earthquake in X direction, but with the eccentricity positive. So we have to select earthquake and then add, and then we have also the negative eccentricity direction. We have in X direction. We have also the earthquake in Y direction, and the eccentricity in the positive direction is EYP, and then the negative eccentricity direction. So these are the load case we are going to use for our structure. So first of all, we can define the self-weight. The self-weight, to define it, is load self-weight, and then you put here -1, then click on add, and that's all to define the self-weight. The other type of load is the flow load. So to define the flow load, you need to click on this 3 point here to define the load for the flow. So let's restart here, typical load, typical flow, typical flow, and then we select the load we are going to use. For the typical flow, we have minus 30, and for live load applied on the flow, it's minus 75, and then we click on add. Then we can define also the roof flow. Here we have minus 10 and minus 20. This is how we define the load on the floor, and then we can click close. And the distribution is two-way slab. So first of all, we can select this first flow and we activate it alone. So we can apply this load here. The application of the flow load is really easy. So we are going to apply it in minus Z direction, and then we are going to follow to define the area where we are going to apply it. So here we need to apply it to we need to copy the flow load on the other flow automatically. And the distance we are going to use here is 12 feet in Z direction. So, but the number here is 10 flow. At 10 time, we need to copy 10 time. The distance in Z direction is 12. Then we need to select the area where we are going to apply the load by clicking in this, and then select area here like this. So this is how to apply the flow load. You can check how it's applied, and we can activate all the building. So you can see how the load is applied on the flow we have defined. So to see the load, you can click on display load, and then go to flow load, and then click on apply to see that we have applied the load on each flow. Then we can apply to the roof flow. We can first select the roof, and then we activate only the roof so we can apply it properly. But this load, we will not cap it. It's just on the roof, and then we define the area of the load, but we need to change the type of the load here for the roof flow, and then we click in the green area to define to assign the load on this area. That's how we can assign the flow load on the structure. It's really fast. So I'm going to define the wind load also using Eurocode. So for the wind load, I have to click here on wind and then add. So the code I'm going to use is Eurocode. The terrain category, I'm going to use category 2. For the friction coefficient, for rough, I consider that our building is going to be erected with a rough concrete. So for rough concrete is 0.2, and I consider the velocity as a default value, and I'm going to consider the automatic parameter for the wind. Then because it's x direction, then I also to define also the gust coefficient for the structural is the structural factor. If you enter the value of the frequency, if I say that the natural frequency of the wind is 0.28, then I can click calculate, then other parameter will be calculated automatically. All you need to calculate using your hand, they can be calculated here automatically. And this factor here, the gust factor, will be calculated automatically for the wind application. Because it's X direction, then I have to put here 0 because we don't need Y when we are using X direction for the wind. So after that, I told you that we can define additional wind load here. If you want to specify this, the flow you are going to apply the load, you can check them, the start story and the end story, and then you are going to click apply. But in our case, we are not going to define the additional wind load. So after defining for X direction, then we click on apply. Then we select for Y. For Y direction, we are going to change only the direction of the wind, specifying the wind load direction factor, and in Y direction is 1. So I hit on apply again to define the wind load. So you can see this this arrow, this for the wind, it's applied on the center of the mass of the building. To perform the dynamic analysis, we need to convert the self-weight into masses, but converting the self-weight into masses sounds crazy, but it means that we are going to express the mass in terms of the load over the acceleration. That's the meaning of convert self-weight into mass. So we are going to check this box here, and then we are going with the input for the gravity acceleration is the same as you know, and then we are going to hit on OK. What is that? Yes, we select this, and we are going to distribute the mass in X and Y direction. Yes, and then we hit OK. So we have to go to load and hit on load to masses. So we are going to define the mass direction as we specify X, Y previously, and then we are going to select all the type of the load to be converted. But the conversion, I just explained it, is not converting the weight into masses, but is the way to express the mass in terms of the load over the acceleration, because we are going to use the mass in the analysis, in the dynamic analysis. So we are going to define the load case and the factor of 1 for the dead load, and for live load we are going to check the factor for 0.25, and then we are going to click OK. So that's why that's how we convert the weight and other force into the mass. So this is going to help us to perform a dynamic analysis. So the next step is to define the seismic load. Seismic load is here, load, and then seismic load here. I'm going to use Eurocode 8. So the first load is there, the earthquake load in X direction. So I'm going to use type 1. Type 1 is for the strong earthquake, which starts for the magnitude of 7 and above. So the ground peak acceleration, I'm going to select the default value so we can go quickly. The term is rushing. And for the behavior factor, I'm going to use this factor, but you need to calculate it when you are, depending on the project you are doing, and the lower bound factor B and importance factor, the factor that I explained before, I can choose for the third building category. And for the structural parameter, we can define the period for just one second, and because we are in X direction, here we can put 0, and then we select the accidental eccentricity for positive, as we specify the load case is positive, then we select positive for the eccentricity. So also for additional seismic use, seismic load, you can hit on add and define the additional seismic load applied on different floor, but in our case we are not going to do that. So after selecting the ground and this parameter for the soil and important factor, behavior factor, and specify the direction of the wave, then you hit on apply. And then the second one is x direction, negative eccentricity. I use the same value and then I click apply. And then in y direction, choose the same value, but the direction, because it's in y, I put 0 in x and 1 in y. And here the eccentricity is positive. You can select here positive and then apply. Then y negative eccentricity, we select negative and then we click on apply. It's on the structure. You can realize that the loads are applied on the center of mass of the building. So if you click on the top, we can click on the top view, you can see that the loads are applied there. You can check seismic load to see them. In x and y direction, they applied on the center of the mass of the building. And their value, if you want to check them, you can activate this function load value, and then you're going to check the value of the load. So we have defined the wind load, the seismic load, dead load, and live load, the roof and flow load. So we are going to, this is going to help us to analyze the response spectrum analysis. To define the response spectrum analysis, it's a dynamic load. We need to select dynamic load and then hit on response spectrum analysis. Then we have to select the function we are going to use. Because we don't have any specific data, we are going to use this. And as we specified in the seismic load, we are going to select type 1 for strong seismicity. So we are going to select this default value, but we need to calculate this one separately and input the value here. And for the important factor also we selected 1.2, but for very important building we go to 1.4, like hospital and power plant building we can select 1.4. For schools having a lot of people we can select also 1.4. And for the damping ratio, yes, for concrete it's just 5%. And then the maximum period is 6. Then we are using the default value for this seismic load, and then we continue like this, and then this one will be generated like this for the design spectrum. The software can give directly the parameter we need for the seismic load in the spectrum. I showed you previously in the PPT file. I showed there is S point here, and then TB, TC, and TD here, the period. Those data, they can be generated automatically after selecting the design spectrum you're going to use. And the one I use it, so we are going to use the horizontal design spectrum. Okay, the same value are selected, and the behavior factor, and then you can see that it is changed to the design spectrum. And the value we need, they are there in this area here, and then I have to click apply. The spectrum function is defined here in this area. After defining this spectrum function, we need to define also the response load case using this function, this load we are going to use. So here we are going to go to load case name. We can say Rx for response spectrum in X direction. So the direction we choose to distribute the mass is in XY direction, and this is going to be the direction of the wave, the seismic wave, seismic action. The excitation in X is 0. The scale factor, after some calculation, you can find the value of the factor is 0.125, depending on the structure you are analyzing. And then you have to select the function. After selecting the function, then you can select the spectral data. I'm going to use linear, and then if you want to consider accidental eccentricity, we considered it in the when we define the seismic load, so we need to check it also. After checking that, we have to click add. So we have to define the response spectrum in X direction. The next one, we have to define also the load case in Y direction. This one, we use the same factor in Y, but the excitation angle in Y direction is 90 degrees. So we select the same function because it's in the horizontal direction. So we use the same linear and accidental eccentricity, and then we click on add. So we have two response spectrum load cases in Y and in X direction. So these are the load. After defining this load, then we can specify the model shape using eigenvalue control. So we can go to analysis and check. We can put the control for this eigenvalue analysis. We can select this method and put the number of frequency. You can start even by 10 or the number you want, but the objective is to check the mass participation percent if it's 90% and above. That's the key for this one, because if the mass participation is lower than 90%, then you need to check your structure very well so that the mass can participate very well in the design process. So I'm going to start to put 20. So I'm going to have 20 model shape. As after defining that one, we have to go also on P delta control. So I'm going to use the load case for the dead load. I'm going to use the dead load with the scale factor of 1 and the live load with the scale factor of 0.25, and then I click on add. Then that's all. Then I click on OK. At this step, we have defined all we need for the analysis. So if we perform the analysis now, we can check the different results we can find. So if I hit on run analysis, then the software will analyze the analysis we have performed. So after defining the load, the boundary condition, and define the material, everything, then we can run the analysis. So we can run it. I'm really sorry for the time. For sure, I didn't know if it's going to take a long time like this. I'm really sorry, but we are going to finish very soon after designing, because this is just the part for analysis. We can wait for the software a little bit, then after performing the analysis, we can check the result. I hope that you can see my screen. And then this is the file we're using. So we are going to define the analysis parameter. So after defining the parameter in the analysis, then we are going to run the analysis and the design at the same time. So here we can define the design code for concrete, going in design menu and then RC design. So here we have I'm going to select ACI design, and I'm going to choose special moment frame. So using this design special moment frame, they are really economical, so we can use them easily, and it's really good for seismic design, this special moment frame. And the method I'm going to use is selected here for max, using the shear for the design for shear, and then for the member type for excluded in the seismic design, they are there. If you want to include the torsion design, you can select here and then you hit on OK. So after defining this parameter, this design like that, you can go and check again here in RC design and specify the strength reduction factor. As you all know, this factor, they are the same as this factor we have learned in school, so they are same. You can check them very well, and if you want to update them, you can click here. They will be updated. Then to design the bar, you can check also the modification of the material, because we're using only concrete. So in this step, you need to specify the code you are going to use for reinforced concrete. The grade for the main rebar, you need to select it, and then the grade for sub rebar, you need to select it like this. and then you click on modify, then the software will consider also the reinforcement in the concrete. After modifying the concrete material, then you can go to design criteria for the rebar, because in our case we have beam design and we have also column design. We didn't define any brace, so we are not going to use this one, but we have the shear wall design also. So when you open this dialog box, you need to select the main rebar, and you can select a number of 2 to 5 rebar, and then the software will select the rebar that is okay for the section, and it's going to indicate it from the report when you are going to generate the report for your design. So here you need to select the number of rebar you are going to check, up to 5 like I did here, and then you select the bar for the stirrup, the side bar, and then you need to put also the side bar dimension, DT and DB, and you have also to specify the spliced bar. You can define the quantity of the spliced bar as 50%. For the column, also need to select the main rebar, the ties, spiral, and then you select the bar you are going to use. Then you need also to select this spliced bar here for 50%. And for the shear wall, similarly, you need to select the bar and then the horizontal rebar, and then the end rebar you are going to use. After inputting this data, then you click on OK to confirm this data in your design. After doing that, you can define also, if you have some brace you are going to use in the design, you need to specify them using going in generate design parameter. Then you're going to select unbrace if there is no bracing stuff in your model, and then in Y direction, but in Y direction we have bracing here, so we select here. After selecting, then we click OK. The other stuff to check, it's about the unbraced length. So this one, if you don't, in our case I didn't consider the lateral unbraced length, and then when you consider this unbraced length, you need to select all the structure, and then you click on apply. After specifying this design parameter, then you can run the model and the design at the same time. We can run it, and then we can check if it's running very well, the analysis. After a few seconds, it's going to finish the analysis. We can wait a few seconds, only a few seconds. Okay, the analysis is over in 20 seconds. So you can check the result. You can go to result to check the reaction. I'm going to show only very fast here the different results. When you see the red arrow, it means the maximum of the reaction force due to the dead load. And I didn't show you how to generate the load combination. In analysis, when you go to design, you can generate the load combination of the design you are going to perform the design based on the code. So you can also check the other result using this table result here. If you want to check for, let me check some design you can need for if you want to check the result for the story, you can check the story drift, the displacement of the story shear, story mode shape, everything. You can check them here easily. And for the mode shape, as I told you before, you can click on mode shape here in the result and check the vibration mode shape here. So for the vibration mode shape, you can check the modal participation masses inputs the way I told you. So you can see that in X direction, the mass participation reach even to 100%, as you can see in this column. And in Y direction, it's reached to 97. So this is how you can check if the analysis you are doing is okay, checking the model participation masses according to the design code. Also, you can check the period of each mode, and the frequency of each mode, they are listed here. So this is when you perform this eigenvalue mode, then you can confirm that your result you are going to find in a response spectrum analysis is going to be good. So for the design of column and beam, we can go here in design, then RC design, then we can check the design for beam as we define all we need to design the beam. We can wait because I didn't select the specified beam, so it can take a little bit long, but it's not more than 20 or 30 seconds. We can wait a little bit and then I'm going to finish. So while the software is running, I don't know if you have some questions, so I can open your mic. Then if you have questions while the program is running, you can have some, you can ask, then I can give you some response based on what you want to know about the software in a seismic design.
Yeah, hello?
Okay, hello.
Yes, good afternoon.
Good afternoon.
Yes, I was just asking if you have some sessions, various sessions using design of building using this gen. Starts from modeling, maybe some short sessions, starting maybe just the modeling as it is. Then you come to maybe just the design as it is. Then you come to this seismic analysis or such kind of things. Can we have such kind of short sessions which someone can start from scratch and go step by step?
Okay. Thank you for your preoccupation. But when I explained in the beginning of this session, I said that if you want some training, special training, you can send me an email so we can customize the session, so we can explain you deeper about the software, because in 1 hour we cannot learn everything about seismic design. So if we can customize some section with you, then we are going to start from the beginning, as you said, from the modeling, the geometrical modeling, and then we are going to do the analysis. So from that, we can make some small session depending on your needs. So I hope that you can send me an email so we can work on that, we can schedule that, and then we can make some meeting online, and then we are going to learn Midas Gen very deep.
Okay.
Okay, I hope that I'm waiting for your email. Is there another?
No problem.
Is there another question? Thank you for your question.
Now, maybe I can also ask another one.
Okay.
The Gen 2023 version.
Yes.
What features, what extra features, or is there a big difference with the previous version, Gen 2019? What had changed so far, or still they can be used?
Okay, usually in our company, we usually do a big update of the software in based on one year. So to get the information on how they do some performance in the previous version compared to the new version, we have the release note every year. So if you go on our website, and then you can write the release note of Midas Gen 2023, then you can check the difference with the previous version very easily. Or I can send you the difference of the Midas 2022 and 2023. You can send me an email, then I will show you the documents that specify the difference between the two versions.
Okay, and what are the current subscription now? If someone wants to upgrade from the lower version to this current version?
Yeah, it's easy. It's really easy. You can just if you have Midas 2022, then you can send me an email if you want to upgrade, and then I'm going to tell you about the process to upgrade the software.
Okay.
Okay, thank you very much.
Hello.
Hello.
I also have a question. Thank you for your presentation.
Okay, I'm really sorry for the time. I didn't know if it is going to take this very long time.
Yeah, it's okay.
Thank
For the software that is Midas Gen,
Yes.
what's the difference with working out this exact thing in Midas Engine?
The difference of Midas Gen and Engine.
Yes, what's the difference with doing this exactly in Midas Engine? Is it also possible, or there are limitations?
Okay, there are some features that are special for Midas Engine that are not in Midas Gen. And if you want to know more about the difference between the two software, then you can email me, then I will explain you the difference between the special feature that Midas Gen has and they are not in Midas Engine. So is there another question? I don't know if you see this, it's finished running. Hello?
Can I ask one question?
Okay, there's no problem, you can ask.
Okay, thank you for the presentation. I couldn't get where we consider the ductility class in this seismic analysis.
The ductility class of the building is designed when we want to perform the capacity design. So let me show you the where we can specify those parameters. So when you go in design menu, you can see my screen, right?
Yeah, yes.
Okay, you go in design code. So when you have this design code here in to specify the ductility, okay, it depends with different code. Let me choose Eurocode. So maybe you can understand with Eurocode. In Eurocode, if we use Eurocode, for example, when we select the design for the code we are going to use in the design, so you can see here there is select ductility class. So you can select high ductility, medium ductility, and the low ductility. So depending on the purpose of your design, you can select this class also, because as I said that it's really difficult to explain every part of the dynamic analysis. So you can mail me and we can have some separate session so you can understand deeper about the RC building design and the seismic load. So we have everything. Even so, when you define these parameter to analyze the ductility, then you can check also. You can check also the ductility here in RC strong column weak beam. So this is the ductile design. You see this one is activated. So you can analyze also the building based on the ductility, and it will verify the ratio between the two moments we analyzing to make sure that all the building is ductile. I think that I respond to your question. Do you have another one?
Thank you. I'm finished.
You're welcome. Is there another question? Okay, if there is another question, then I think that it's too late, and I'm really sorry for I didn't keep the promise to keep the time of 1 hour, and I was really surprised because it's not easy to make the summary of a full design like this in a few hours. So maybe when you need any support or technical support, you can ask me by email, and then I'm going to explain deeper about the design. So after running the design, this is, I don't know if you can see this this dialog box about the beam design. Can you see it?
Yes.
Yes.
Okay, if you can see this dialog box, then I can explain it. So when you design the member, the beam member, you have the section of the beam. Because we have only one section, we can expand this like this. So you can see that I can select the section for the beam, and you can see the color is in blue. When you have the result and then in this page you have blue color, it means that the section has passed. And if you want to check for the section that has passed, you can filter by clicking on OK. OK means that you are going to look for the section that has passed the design, and then NG it for the section that didn't pass. So for the beam design, you can see that all is in blue. So you can check the section by clicking on the graphic report. Can you see the graphic report also?
Yes.
Okay, thank you. So this is how the software can present the design of the beam, giving you the bending moment capacity, the shear, and the reinforcement ratio of the beam, everything you need to after you when you are doing the design for the section. So if you want to have the detailed report, you can click here on detail. The detailed report cannot be seen on the screen. Let me share with you. This is the detailed design that Midas Gen can produce after designing everything. So you can have all the process the program did for designing the members. So this is beam design. So after beam design, you can design also the column by going on RC design and then concrete code design and then column design. And for your news, that for those who won't get the software, they can email me so we can have some discussion about what they want and the project they are running, because our technical team can help you running your project when you ask for a special session training. So be free to ask for training in order to learn very well. This software is really good, and I recommend you to do that in this coming week. So after designing the column and the wall, and that's the process. We did everything. So you have seen everything. So after this design of column is finished, then we can finish this session. But if you have any question, you can still ask, because the design of column can take some maybe 30 seconds or 45 seconds to be finished. The question can be even asked in different languages, because I can speak 4 languages. So if you can speak even French or Kiswahili, you can ask the question in those languages and I can ask your question. There are people who raised their hand, but they didn't speak maybe. I can see the one who raised his hand is Mr. Engineer Dejen Mekonen. I don't know if he's still there, but he raised the hand.
I have asked it. That's fine.
Sorry?
I have already asked it about the.
Okay. Is Mr. Frederick Ogada, and the other one is Engineer Speki.
Yeah, I already asked the questions.
Okay, thank you very much. So what kind of project you are working on this day in your company?
Road projects, bridges, and the bridges especially.
You are working on bridge. What type of bridge are you working on?
Yeah, just the normal bridges, the steel composite bridges, and the normal reinforced concrete ones. Yeah, short spans, basically 20, maybe 20 to 30 spans. So these are the typical spans that normally we use.
Okay.
as major box culverts. At least those are the ones.
We have also project for box culvert.
Yes, box culvert are just a minor, normally typically common in most of these. Yeah, but mainly bridges, so medium, short to medium sized bridges, multiple spans. So those are the ones that we normally have.
So what program do you use to make the design of those bridges?
We are licensed with Midas Civil. So we have been using Midas Civil for a very long time now.
I see.
Yes, and we get support from Midas team.
Okay,
So several times when we and we have I think we have the 2023 version. The 2023 version, I think that is the one we are using now.
Okay, that's really good.
2023, yes. Yeah.
When you need some technical support, yeah, you can still ask if the company is going to help you very much.
Yes, sure.
Okay, thank you very much. So the column design is finished, and you can see that the section for all the column is passed. And to check the graphic report and detail report is the same. But when the section didn't pass, you can change the bar in this part. So you can change the bar information in this design criteria for rebar, and then you run again the design analysis. So until the bar or the section has passed, then you can stop the analysis and you can proceed for the construction project. So thank you very much for attending.
Question.
Okay, question. Okay.
Serik, eh?
Okay.
Hello?
Okay, hello.
A small question about the ratio of the steel in a section of concrete. That's the first question. The second question is about the density, the kilogram of the steel in the concrete. How to see it?
The ratio I'll show you in the report. Because the report I just show you for the beam design. In that report, we have the ratio of the reinforcement, the amount of the reinforcement you are going to use in the section of the beam, the column, and the wall.
Okay.
Okay. We don't express the amount of steel in terms of density because we already express it in terms of ratio. That's the amount of steel in a section. So if you have the amount of steel in the section using the reinforcement ratio is the amount of the steel. So it's the same stuff you are talking about. The density, you can define the density of those material in the material property of the steel. Maybe when you want to use the steel material, you can come here in steel, and then you can specify the density of the steel you are using. Maybe in this way you can specify the density of the material, but in the design part we just give you the ratio, the reinforcement amount of the steel reinforcement in a section. I don't know if I answered your question, Engineer Eric.
That is, I can understand. But what about the bending moment, the results of the bending moment, shear force, and the results of the bending moment?
Okay. Let me show you the result for, because we are going really fast, so I didn't show you all the result that we have here. But for the bending,
okay, the diagram.
For the bending diagram, okay, let me show you there. forces and okay, beam diagram.
Okay.
So this is the result for beam. You can see the results in terms of you can check the value here in this box, and then you click apply. But you can select few members so you can see them clearly.
The maximum value. Okay.
Sorry, I say that you can select, if we select one member, then you can see the value clearly because there are a lot of value for the moment. So if you select one member, then you can see the value
And
very
even the
clearly.
stresses, I can see the stresses.
You can find for shear, it's there, the result is there in this option beam diagram. So I think that until it's about 2 hours we did in this webinar. So
okay,
I think that we are tired. We are all tired. So for more training, please email me. Sorry.
I want to say only to thank you, Ali. I want to say thank you very much for the exposing.
Okay. You are welcome.
It's a pleasure.
Thank you very much for attending this webinar. I really love your courage to follow until the end. I'm really surprised that you continue watching. Thank you very much.
Okay, thank you again.
We are going to communicate in this week, and if you want more training, then you can email me. Then I will try to explain everything you need to know about Midas Gen and other products of Midas IT, because we have a lot of products.
You are welcome. Thank you very much.
Thank you very much, and have a nice day. We are going to meet very soon. Send me the email, then we are going to continue the training.
I'm going to send.
Okay, bye everyone. See you next time.
Thank you very much and goodbye.
You're welcome, sir.
Thank you. Have a goodbye.
You're welcome. Thank you very much. See you too.